All right, this topic is on solving quadratic inequalities. So we spent some time in a prior chapter on graphing linear inequalities. So we graph the line, we would shade it above or below the line. That's what we're going to be doing today, but with quadratic inequalities. So here are the steps. You want to turn an inequality into an equation and then graph the parabola by finding the important parts, the axis of symmetry, the vertex, the y-intercept, and the x-intercepts, which represent the zeros. Then you want to find the solution, or the zeros. Those are going to be your x-intercepts. Then you would make a number line with the zeros and check each solution. You want to write your answer in interval notation. Lastly, you want to shade the appropriate region. So we would shade below or above the appropriate region. So here's our first example. Graph the quadratic inequality that is in standard form. So we have y less than negative 2x squared minus 4x plus 6. So I'm just going to go ahead and change that to an equation. Y equals negative 2x squared minus 4x plus 6. And then we would identify the a value, the b, and the c. Notice that this is going to be concave down because that a is a negative number. So this is our a, and that a is less than 0. So it's going to be a parabola that looks like this, going to open down. That a is also going to be narrower than the parent. So it's going to stretch it. Since that parabola is going to open down, it's going to have a maximum at that vertex point. Step 2, let's go ahead and find the axis of symmetry. So we're going to use the equation x equals negative b over 2a. So we substitute in the value of b, which is negative 4, the value of a, which is negative 2, and then we simplify that. So the numerator will be 4, the denominator will be negative 4, and we get negative 1. So you want to write that equation as x equals negative 1. So I'm going to go ahead and graph that. So there's my line of symmetry. Then I want to find the y coordinate of the vertex. We already know the x coordinate runs through the axis of symmetry. So we're going to evaluate the function for f of negative 1. So we substitute negative 1 into the function. And then we would just use our calculator and simplify that, or do our orders of operation, and when we're done we get 8. So the vertex, the x coordinate is negative 1, and the y coordinate is 8. So let's go ahead and graph that. So there's our vertex point. Next we want to find the y-intercept. We would evaluate the function for 0. And then we would simplify that using an orders operation or our calculator. And what we get is 6. Notice that is always going to also be the c in the equation when it's in standard form. So then we go and graph 0, 6. In a prior chapter we learned about the pink line, and we have a reflection point. So we have an additional point right there, reflected about the pink line. So we have now 3 points that we could then create our parabola. What we're going to do next is to find the x-intercepts, or the zeros of the function. So we're going to set the equation equal to 0 to find our x-intercepts. And we're going to use our factoring methods. We're going to factor out a GCF of -2. So we're left with x squared plus 2x minus 3. So that is the GCF. Then we can do the diamond. The factors of -3 that add to +2 are +3 and -1. So again, we do have that GCF outside, and now we have our 2 binomials. The sides of the diamond help us to make those binomials. Now we have it in factored form. We can now use our zero product property. We can set those factors equal to 0 and solve for x. So our x-intercept, the first one is -3, 0. Then we set the other factor equal to 0 and solve for x. So our second x-intercept will be at 1, 0. So let's go ahead and graph those on the coordinate plane. So now we have 5 points. Now I'm going to go ahead and start to graph the parabola here. Notice that this inequality does not have a line underneath this. It's not equal to. So when we graph this, we are going to be not creating a solid parabola. We're going to have a dashed parabola. So then we go ahead and create our dashed parabola. And before we shade the appropriate region, we have to test to see, does this parabola need to be shaded outside the shaded region or inside the parabola? So that'll be moving on to step 6. So step 6 says create a number line. So here's our number line. And we have our x-intercepts are going to go on that number line. We call these critical points. So these are our zeros. And we want to test the inequality. So our inequality was y less than -2x squared minus 4x plus 6. I'm going to go ahead and change that y to a 0. And we're going to test the 3 interval regions. So the first interval I'm going to test is to the left of the critical point, -3. So I'm just going to choose -4. And I'm going to see, does this hold true? So I would say 0, less than, and we replace that x in the inequality with -4. And then we would simplify it. And we get that. Let's all read it. Is 0 less than -10? Is that true or is that false? Is 0 less than -10? No. Or is -10 greater than 0? So that's false. So I'm just going to put a negative there. Then I'm going to choose my next point between -3 and 1. So I'm going to choose the number 0, and I'm going to test it. So I'm substituting it into that red inequality. And then I simplify it, and I read, is 0 less than 6, or is 6 greater than 0, which is true. I'm going to go ahead and put a plus symbol there. That's true. And I have one more region to check. So I'm going to choose the number 2. So x equals 2. So something to the right of that critical point. And then I simplify it. And then I read it. Is 0 less than -10, or is -10 greater than 0? That is also false. So I put a negative here. So what does that tell me? It tells me that my solution is between -3 and 1. That's the region that I'm going to shade. So now let's go down. And where I'm going to shade is between -3 and 1. So I'm shading between those x-intercepts. And that region is my solution. And I want to write my answer as my interval from -3 to 1. Where did I shade? I shaded below my parabola's vertex, and it's going to be a dashed line because it doesn't equal.